Hello friends, welcome to my YouTube channel Quality Talks. In today's video, we are going to explore a vital concept in quality management, that is Measurement System Analysis or MSA. Why is MSA so important? Because every decision we make in manufacturing or quality control is based on measured data. If your measurements are inaccurate, we risk making wrong decision, and that can lead to major quality issue, rework, or even customer dissatisfaction. MSA helps us understand and quantify the error in our measurement system, so we can be confident that the data we use for decision making is reliable. Whenever we measure a part or process variation, the total variation we observe is made up of two main components. One is actual part or process variation, and the other one is measurement system variation. If the measurement system variation is too large, it can mask or distort the actual part variation and leading to wrong decision or incorrect decision. But when the measurement system variation is small, we can make accurate judgment about the true variation in the process or part, which leads to a right decision. So what exactly is measurement system analysis? So as per AIAG, measurement system analysis MSA is a statistical tool used to evaluate the capability of measurement system to produce valid data. Now let's see the elements of measurement system. Measurement system consists of four key elements: the measuring instrument, the operator or inspector performing the measurement, measurement method, and the environment in which the measurement takes place. All of these elements can contribute to measurement error. For example, the instrument may have calibration issue, poor resolution, or lack precision. Inspector may introduce variability due to skill level or fatigue, or there can be a appraiser variation. It means inspector to inspector or appraiser to appraiser variation. A method may be poorly defined or incorrectly followed. The environment may introduce noise such as temperature change, vibration, lighting condition, etc. Now let's discuss two key concepts in measurement system analysis: accuracy and precision. Accuracy refers to how close a measured value is to the true value or reference value. In simple terms, it shows the deviation of observed value from the true value. Precision, on the other hand, refers to the closeness or consistency among multiple observed values. So it is simply the spread of the observed value. The variation observed in the observed value is called as precision. If repeated measurements are very close to each other, they are considered as precise measurements, even if they are not accurate. To visualize this better, let's look at this figure where the center point represents the true or target value. In quadrant 1, the measurements are very close to each other, as well as they are centered around the target. So the measurement or observations are having high accuracy and high precision. In quadrant 2, measurements are spread out but still centered around the target. So we can say these measurements are highly accurate but not precise. In quadrant 3, the observations are very near to each other but they are away from the target. So we can say they are highly precise but having low accuracy. In quadrant 4, measurements are scattered and far from the target. So they are not precise nor accurate. Let's understand the definition of accuracy and precision. So accuracy is typically defined as the difference between the observed average and the true average. Accuracy error can be categorized into three types. Bias. Bias is the consistent deviation from the true value. Stability, the variation in measurement over time. Linearity, the change in measurement bias across the measurement range. Calibration processes are used to detect and correct the accuracy errors. Precision reflects variation within the measurement system. The higher the variation, lower the precision. Precision errors are divided into two categories, repeatability and reproducibility. Repeatability, variation when the same operator uses the same equipment under the same condition. Reproducibility, variation when the different operators uses the same equipment under same condition. Gauge R&R studies are conducted to estimate precision errors. By understanding and controlling both accuracy and precision, we can ensure that our measurement system delivers reliable and consistent data, which is critical for quality assurance and decision making. In MSA, we aim to understand the total variation in our measurement system. This total variation can be broken down into two components: part variation and measurement system variation. Our primary focus is on the measurement system variation. We want to assess how much of the total variation is due to measurement system. The measurement system has two main types of error: accuracy and precision. Accuracy error. Accuracy refers to how close a measured value is to the true value. It includes three types of error: bias, linearity, and stability. We perform calibration to detect and correct these errors. Precision is about consistency of measurement. It includes two types of error: repeatability and reproducibility. We estimate these using a gauge R&R study. Let's discuss about accuracy errors. Bias. Bias is the difference between the observed value and the actual value. Linearity refers to the change in bias across the measurement range. For example, as shown in figure, from 0 to 20 mm, bias is 0.01. From 20 to 50 mm, bias is 0.015 mm, and 50 to 80 mm, it remains 0.015. From 80 to 120 mm, it increases to 0.02, and from 120 to 150 mm, it reaches 0.05. This variation in bias across the range is known as linearity error. Stability refers to change in bias over time. If the same instrument gives different bias at different times, it indicates a stability issue. We do the calibration to estimate the accuracy errors. It is essential to eliminate accuracy related errors through calibration before conducting a gauge R&R study. Precision is about the consistency of measurements. It includes two types of variation: repeatability and reproducibility. Repeatability, it is also known as equipment variation. It is the variation when the same operator measures the same parts using the same instrument multiple times. Reproducibility is the variation that occurs when different operator measures the same parts using the same instrument. This reflects the variation between appraisals. Let's also understand a critical concept called NDC, number of distinct categories. NDC tells you how effective our measurement system can detect variation in the process or part. Imagine we are measuring parts with the actual value of 10.1, 10.2 and 10.3 mm. If we use a measuring scale with the least count of 1 mm, then all reading will be 10 mm. This means system cannot distinguish between the parts. It fails to form meaningful categories. As a result, our decision based on the data would be incorrect. If system can only form 2 or 3 categories, the output is considered as attribute data, which is not ideal for precision decision making. However, if the system can create 5 or more categories, it is capable of making more reliable and informed decisions. Mathematically, NDC is the ratio of the standard deviation of part variation to the standard deviation of the measurement system. In next video, we will walk through a real world MSA example. We will calculate equipment variation, appraiser variation, gauge R&R and NDC. If you found this video helpful, please subscribe to my YouTube channel Quality Talks and don't forget to share your feedback. Thank you very much.